This is that Marshall JCM 2000 DSL 100 with the new board in place. This is going to be another one of those videos where I have a 10-15 minute video that represents 3 hours of work. So, some guys really like the long videos. I see most people watch 10 minutes of them, which is kind of frustrating. So I'll still do the occasional long form video when I think it makes sense or really conveys something that is lost any other way. But in general, short attention spans are the name of the game. Now, this is the old board, and it's got lots of mistakes. Number one, these old boards are conductive. And I didn't see this because the output board covered it up in place, and I already knew that this board was bad, and no need to do elaborate tests when you know the thing is junk. But look at these output coupling caps here. This one split, this one is split. These were exploding. That's how bad the output section leakage can get on these, or these caps, 630 volt rated caps. Fine capacitors were just in an untenable operating condition, and they didn't ten. They gave up the ghost. But in place like that, with the board over it, it was hard to see. So I didn't see that on the initial inspection. I saw enough from the board revision number 4 or 5 to say, no, that won't make it. So I've got the new one here. And like on the previous one, in the video titled Grumpy Tech, Why is Grumpy Tech So Grumpy? Which is linked below. Just like that, I had to go through and redo all the capacitor solder joints, get them all flush to the board, well secured, had to remove the stock bridge rectifier, which almost invariably burns the board, and mount the new one up high. You can kind of see it there. It's mounted up almost an inch off the board for better heat dissipation. And as pointed out in the previous video, refloated all the solder joints on the jacks and the impedance selector switch, cleaned all the pots and switches, and bridged right here, that 16 gauge. Doesn't look like much, but it's much more than adequate for the current between here and here, so that if you use the 8 or 4 ohm setting, you won't lose your ground and then toast the output section. That's one thing which can contribute to those old boards have a hastening failure. There are 2 connections on this new board. Let's see, one's here. Wait, where is it? One's here and one is here, which don't exist on the old board, or they just have little solder dots where no part was placed. So that's a little bit tricky to go back and forth. The bias board here, I took out and I reflowed the solder and cleaned everything, and I verified the pots were still good, and I cleaned the pots. Sometimes these things get chewed up from people using the wrong screwdriver. These seem just fine. And I always confirm here on this part of the board for these that C46, in this case, is a 2 kilovolt, which is fine. The old board had this little 500 volt, and that's between the plate and screen. It's there, in theory, to stop oscillation. In general, though, it just shorts out because 500 volts is not adequate for that. And it shorts, then you have big problems. This whole thing is just made of big problems. The new one should be much better. So let me put the output board back in place and put the preamp tubes in place, and then we'll do some tests before we install the output tubes, new EL34s. Well, I just wasted a whole bunch of my time because I didn't think Marshall would F up as colossally as they have on this brand new board for $200. But as you can tell, this resistor has been changed out. According to the schematic, it's supposed to be a 10K. What was on there was a 3K. This one's been changed out. These are temp things. I'm going to order some 1 watt specifically for it. This was supposed to be a 33K according to the schematic. It's a 22K. But I still couldn't get the bias range right. It was just crazy, like negative 15 as opposed to negative 50. Then I noticed this. Some of you probably saw it already. They installed this cap backwards. The positive's on the wrong side. This is in the bias supply. That's why the entire thing's way the F off. Let me show you what the bias supply on this actually is doing. They make it really complicated in the schematic because it's all broken up on different pages and nothing's shown connected as is. But you have two different AC secondaries coming in. They go through some capacitors. The values aren't important here. Standard diodes. The other side of this same dual AC supply is used to make a positive supply for something else. After the diodes, it's all negative voltage, DC. Goes through this 10K, was actually a 3K. Has a 47 microfarad to ground. That one is installed correctly. Then it splits to two 22K trimmer pots, one for each side of the output, and then through a 33K, which was a 22K to ground. And then once you have point A and point B, the output of the phase inverter each goes through a 22 nanofarad coupling cap with a 220K resistor to point A or point B. That's the bias reference. And each one has a 47 microfarad cap, and with the positive to ground, that's where they goofed. They didn't have the positive to ground. So I'm just disgusted with Marshall for making a terrible mistake. And I got to go through there and check everything else in this amp. If they made that mistake, what other mistakes have they made, possibly? You know, it's fun. Just swap out the board, they said. It'll be fun, they said. Well, this is not a repair. I removed those capacitors, and with that one that was exploding out, instead of having negative 15 over here, now have negative 48, 46 now, and the same on the other side. So that's a much healthier place to be, negative 46 on either side. That's where the bias trim pot's set to the coolest bias. So that means we're probably going to have a pretty good range. So I'm going to order two 47 microfarad 63 volt electrolytics and install them correctly. I'm going to order the following 1 watt metal films. I'm going to get a 3.3K and a 10K to go in this spot. 3.3K is what was in from the factory, 10K is the schematic, and similarly here 22K and 33K. 22K was what was in there. 33K is what's in there now, a la the schematic. At that point, it'll be safe to power on with output tubes. If I had just put in the brand new $180 worth of output tubes and powered it on with negative 15 volts and negative 8 volts at the grids, bye-bye $180 worth of tubes. So, that said, now I have to go through this entire board and look for any other problems that would be colossal and detrimental to the health of the amp and or the tubes. So, like I said, so much fun.